Okay, guys, so we're going to do an example problem based on the notes, and we're going to figure out the up and down zeros, vertex, axis of symmetry, and the y-intercept. So let's go down the checklist. The first thing we want to do is we want to see if it's an upward or downward facing parabola. Well, if you know, this is a 1 technically, which is positive, so a is greater than 0. So based on our last notes, we would have an upward facing parabola, so we know the shape will be something like this. Then, if we want to find the zeros, okay, so zeros, we're talking about the x-intercept, which happen when y is equal to 0, or f of x is equal to 0. So this is for part 2. So we have 0 is equal to x squared plus 2x minus 3. And we can use one of our x method. We can use the x method right now. So we've got negative 3 and positive 2, which turns out to be a 3, a positive 3, and a negative 1. Which means that 0 is equal to x plus 3, x minus 1, which gives us x is equal to negative 3 and positive 1, because if you plug 1 into here, you get 1 minus 1, which is 0. 0 times this is 0. And if you plug negative 3 into this, you get negative 3 plus 3, which is 0, times this is going to be 0 as well. Okay, so our zeros here are going to be negative 3, 0, and 1, 0. Okay, so that's done. If we want to do the vertex, remember our formula for vertex was x is equal to negative b over 2a, which means that we have x is equal to negative b, which is 2, over 2 times a, which is 1, which means we have negative 2 over 2, which is negative 1. So our x value for the vertex is negative 1. And then if we plug that back in, we have x squared plus 2x minus 3. Notice that I'm going to use parentheses for the negative 1, so we have negative 1 squared. Okay, we're plugging this into here and here. Plus 2 times negative 1 minus 3, which this squared is going to be 1. Plus 2 times negative 1, well, positive 2 times negative 1 is negative 2. Negative 3. 1 minus 2 is negative 1, minus 3 more is negative 4. So our vertex is negative 1, negative 4. And since this is upward facing, I know that this is going to have, well, obviously it would have 2 zeros. That would be my indicator if I had done vertex. If I had done the vertex and the upward and downward facing, and obviously we've already found the zeros, so that's good that we actually got some. The next thing to know is we have the axis of symmetry, which happens at x is equal to negative 1 in this case, because we have the vertex being at negative 1 for x. And so the vertex is the most central point of a parabola, and it's symmetric on both sides. And then finally, if we want the y-intercept, I'm going to just do that right underneath. We have y is equal to, let me go back 1 second. We have f of x, so we want f of 0, this is y, is equal to 0 squared plus 2 times 0 minus 3, which is 0 plus 0 minus 3, which is negative 3. So our y-intercept is at 0, negative 3. And so we have gotten everything from the list. And if we wanted to graph this, I think we probably could. We could go like this. Okay, we have the following. We have a vertex at negative 1, negative 4, so I'll do my best. That's down here. Okay, negative 1, negative 4. We have zeros at negative 3, 0, that's right here, and 1, 0. Notice that it is exactly 1, 2, 3, and then 1, 2, uh-oh. Hold on, I counted wrong. Sorry. Let me recount that. So the distance from here to here is 1, 2. The distance from here to here is 1, 2. And so it's symmetric, and so that's good, because we know that the axis of symmetry goes right here. Sorry, I'm doing my best. And so if we graph this parabola, we can go and draw something like this. And that would be the graph of this parabola given all of that. Notice that it's upward facing. We've got our zeros here. We've got our vertex axis of symmetry. The only thing we don't have is the y-intercept, but conveniently, with the way I've drawn it, you can see that that is 0, -3. And ta-da, we have done this. We have completed this graph.